Hey guys, Miss Neat here, making another 180 video for you. It is Block 4, Topic 2, Lesson 2, and we're going to use models today to add fractions. So your learning target is I can use models to add fractions with unlike denominators. So if we take a look at our do now, you can see that they want you to tell them all you can about 1/2. Basically what they're asking you to do is think about other ways that you could name 1/2 of whole. So you're looking for equivalent fractions here. So 2/4, 3/6, 4/8, 5/10, where your numerator doubled gives you your denominator. That's all equivalent to 1/2. If we think back to our last lesson where we were trying to make equivalent fractions in order to add unlike denominators, we can remember that when we looked at 1/3 and 1/3, which made 2/3, we made equivalent fractions by taking those 1/6 and placing them up there. And we realized that 4 1/6 pieces was the same as 2/3. Therefore, we found out that 2/3 and 4/6 were in fact equivalent fractions. Today, we're going to take that a step further as we start to look at what happens when you have those unlike denominators and you're trying to add those fractions together. So if I begin with my model as always, and I put my 1/3 on there, and then I put my 2 1/4 pieces next to it, I can see I can't add these together because they're not the same size pieces. And in fractions, equal pieces is the foundation. So what I have to do is find a denominator that both 1/3 and 1/4 share. So if I start counting my multiples of 3, I can say 3, 6, 9, 12, and 15. If I then take my 4s and I count by 4s, I count 4, 8, 12. Whoop, I can stop right there because if I have 12 here and 12 here, this is in fact my common denominator. So coming back up to my model here, I'm going to grab those 12 size pieces and I'm going to line them up underneath my model so that they, in fact, take up the same amount of space. So I can see that 1/3 is equivalent to 4 12ths. I'm then going to take 12ths and line them up under my 1/4 pieces. And I can see that 2/4 is equivalent to 6 12ths. And if I add those together, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 12ths would be the total of those two fractions added together. If I take a look at that again, and I want to see the equation that will prove that my model is in fact correct, I go back to my 1/3. I counted by multiples of 3, I got to 12. I have my 2/4, I counted by multiples of 4, I got 12. So my denominator here in both cases will be a 12. How do I get from 3 to 12? Well, 3 times 4 is 12. So I'm multiplying this by 4 over 4. So if 3 times 4 is 12, 1 times 4 is also 4. So that gives me an equivalent fraction to my 1/3. That's exactly what we saw in our model, 4 1/12 pieces. I come over here and I say, okay, 4 to 12 is times 3. I have to multiply by 3 over 3 because that has a value of 1. Identity property says anything multiplied by a value of 1 retains its value. So if I do 4 times 3 is 12, then I do 2 times 3 is 6. 6 12ths has the same value as 2/4. They are in fact equivalent. If I add those together, remember when we add fractions, we add numerators only. 4 plus 6 is 10, and my denominator stays the same, 10 12ths. Now your teachers are going to say to you, is this in simplest form? The way that I check to see if this is simplest form is there any number I can do that is a factor of both of these? Well, I know that 2 is a factor of 10. I can count by 2's to get to 10. I know that 2 is a factor of 12. I can count by 2's to get to 12. So if I divide this by 2 over 2, because I can still make an equivalent fraction as long as the numerator and denominator is also divided by the same value. 10 divided by 2 is 5. 12 divided by 2 is 6. And now I'm in simplest form at 5/6. Or I could have written it as 10/12 because these are equivalent fractions. So if I look back at my model, I can see that 6's would give me an equivalent because when we just did our work in the demo, we saw that 10/12 in simplest form is 5/6. Again, we're looking at the value of these pieces. So these pieces here have an equivalence to 1/3. These same 4/12 have an equivalence to 1/3. These pieces over here, these 3/6, have an equivalence to 2/4. And these 6/12 have an equivalence to 2/4, which allows us to see. So again, I would never add like this. I would always show my equivalent fractions because this is not correctly written in my mind. What is correctly written was how we showed it in our demo, where we were adding 4/12 plus 6/12 to equal 10/12. So 4/12 is what 1/3 was equivalent to, and 6/12 is what 2/4 was equivalent to, which allowed us to then add these together because they had a common denominator right there. There's that common denominator of 12. And then I simplified my 10/12 to 5/6. Look at another example. We can see that if we add 1/2 and 2/8, I can put that 1/2 in my models. I can put those 2 1/8 size pieces in my models. And again, I'm now going to look for a common denominator. So I'm going to start by counting by 2's. So I count 2, 4, 6, and 8. And when I get to 8, I stop because right there I should go, oh, if I can use 8 as a multiple of 2, then I don't need to find a common denominator for 8. So I only need to find the equivalent fraction to 1/2. So if I use my model here, I'm going to take those 1/8 pieces. I'm going to line them up underneath my 1/2. And I can see that 4/8 is equivalent to 1/2. I can then add those 4 1/8 pieces to the 2/8 for a total of 6/8. So again, I can take 4/8 because that's the value of the equivalent fraction to 1/2. These are equivalent for 1/8 pieces and a 1/2 piece. I can add the 2/8 from the original equation, which is right here. And if I add them, I get 6/8. Now again, is it in its simplest form? No, it's not, because 6 and 8 are both multiples of 2, which means they can both be divided by 2. So 6 divided by 2 is going to be 3, and 8 divided by 2 is going to be 4. And if I want to check and ensure that's correct, I'm going to take 3 1/4 pieces and see if they come to the end of what these pieces together would in fact equal. Not 1/3, 1/4, Miss Neat. So we've got 1, 2, 3 1/4 pieces, and there it is. The values are the same. So these two are equivalent, and this is in fact your simplest form. Okay, so pages 164 and 165 in your M Space book are going to have more examples for you to practice with. I modeled what's in blue and number 1. You have numbers 2. Then you also have 3 through 8 and your exit ticket, all of which you can practice with me, finding that common denominator, making those equivalent fractions, and adding those fractions together. With or without models, you have strategies to do this. If you need me, I'm always here. Let me know you need some help, and I'll see you soon. Bye, guys.